Good morning. I am Ranji Jaypal. Today I am going to tell you a little more about image segmentation by clustering models for fingerprint recognition. Here I am going to tell you the working principle and basics of fingerprint image segmentation. In addition, I will explain the clustering algorithms in detail. I will discuss with the supervised and unsupervised learning. In particularly, I am going to cover the linear and non-linear clustering algorithms. Fingerprint image segmentation. Segmentation is a decomposition of an image into the components. Fingerprint image usually consists of two components from the captured image, which is generally known as foreground and background. The place where the fingerprint is applied into the sensor is called the foreground, and the noisy area in the border, which is caused by skin distortion, wetness, dryness, is known as background. So this is the basic output for the image segmentation by using MATLAB function in the left side. To segment objects from a background is known as thresholding. If the background pixel values are relatively uniform, then global threshold is used. If the background intensity values have a large variation, then the adaptive threshold is used. In this project, I used adaptive threshold in the image binarization. Fingerprint image segmentation is split into ridge ending and ridge bifurcation, as you see in the left side image, figure A and figure B. And the figure C shows this is how the fingerprint ridge ending and bifurcations looks like. Although there are a lot of points in this minutia, we just take ridge ending and bifurcation, and then we get the output by using the fingerprint verification system software, which shows the x and y coordinates and theta angles. The goal of the fingerprint segmentation is to classify the object where it's originally originated from the image, either background or foreground. Because the accuracy of the segmentation will help to extract the features like minutia values, as you see in the previous slide. And here the x and y coordinates and theta angles, I put it in the table. So here 1 represent the ridge ending point and 3 represent the bifurcation points. Color image segmentation. In present days, many image segmentation techniques are available. These techniques are classified into 3 methods: clustering or thresholding, region growing, and boundary detection. There are many techniques are available to segment the object or image, but none of them are sufficient to perform across the varied set of images. To achieve this, we are using some of the color image segmentation techniques such as pixel based, edge based, region based, and model based techniques. First, pixel based techniques. Histogram thresholding is one of the simplest technique in pixel based segmentation. Also, it's a popular and most commonly used technique for the image segmentation. Next, edge based techniques. This technique is used to find all discontinuity of the region from the given image. So in here they are classified as robot, Sobel, Canny, Privet, edge based techniques. As you see in the left side image, there's the output by using the MATLAB function. Now I'll tell you what is meant by robot edge detector. This technique is very useful to mask with approximate digitally when the first derivative. Next, Sobel edge detector to find the approximate absolute gradient magnitude at each given input grayscale image values. Canny edge detector, the input value is a grayscale image, then it will produce the output image as place of takes in intensity. Next, Privet edge detector. Edges are measured by using transformation between corresponding pixel intensity of an image. Clustering. By partitioning the given set of patterns into disjoint cluster is known as clustering. This will clarify the details of a given image, whether it comes from the same data or separate, as you see in the left side image. Clustering is widely used technique in most of the applications such as artificial intelligence, neural network and statistics. Although clustering algorithms was good, there are some drawbacks in this algorithm, which is the number of cluster is need to be predefined. The clusters are given by centroid value and it's classified with a Euclidean distance. So the real structure is unable to detect. Most likely color clustering is very difficult to analyze because of their arbitrary shape. As you see in the left side image, some of the pattern clustering activities are classified in Jane and Dubé's 9 books. For instance, pattern representation, data abstraction, clustering, grouping, assessment, and so on. First, the feature selection. To identify the real subset from the original image in clustering model is known as feature selection or extraction. Next, pattern proximity. To measure the distance between the pair of patterns, we are using a pattern proximity model. So here the clustering algorithm is classified in two categories, as we discussed in the beginning, as supervised and unsupervised clustering algorithm. In unsupervised, there is a linear and non-linear. First, I will give this little introduction about supervised and unsupervised learning. In supervised learning, the algorithm is well defined with the data points and the labels that explain the case. In this way, when unseen case comes to be categorized, the algorithm can be able to identify the corresponding label for the case. On the contrary, in unsupervised learning algorithm is given by the data points with no labels. Here the task is to identify the similar label which is correspond to the given data. To combine the supervised and unsupervised learning algorithm is known as semi-supervised algorithm. Now, unsupervised linear clustering algorithm. These are the algorithm which involved in this section. K-means, fuzzy C-means, hierarchical clustering and mixture of Gaussian clustering algorithm. I am going to tell you a little details in this algorithm. First, K-means algorithm is widely used in data partitioning because of its memory space and low computation supplies and their larger performance in finding the region of high density. The partition which object belongs to each other in this method, and there are some categories in this model such as hierarchical, grid and partition based clustering models. So as you see in the left side image, this is how the K-means clustering algorithm works. In the beginning, we define number of cluster K and we take up the centroid or center of this cluster. Any random object as the initial centroid can serve as a initial centroid. Next, fuzzy C-means clustering. By partitioning a given input data into one or more cluster is known as fuzzy C-means. This method is established in 93 and developed in 1981. So as you see in the left side, algorithm is the basic model of the fuzzy C-means clustering algorithm and it's frequently used in pattern recognition. Next, hierarchical clustering. Hierarchical clustering approaches are characterized into agglomerative and divisive. A singleton cluster and recursively merge two or most suitable cluster is known as agglomerative clustering. A one cluster of all data points and recursively split the most suitable clusters is known as divisive clustering. So as you see, this is my output for the hierarchical clustering on the left side image. The same output I get the hierarchical clustering by using the MATLAB function. There are several variations measuring the distance between the cluster, and typically Euclidean distance is used for individual points. Next, linkage clustering. Here there are a lot of types which is involved in this model, such as average linkage, centroid linkage, complete linkage, single linkage and Watt's method. Average linkage clustering is to calculate the difference between the cluster is known as average linkage clustering, and the centroid linkage clustering output results are shown in the left side image. So centroid is a group of average in the variation of time It is also denoted as the cloud point in the center area as is seen in the image. Next, complete linkage clustering, also known as maximum or furthest neighbor method, and single linkage clustering is also known as minimum or nearest neighbor method. Finally, the Watts method is to calculate the average number of square deviation from the mean of a cluster is known as Watts method. Clustering as a mixture of Gaussian. By using certain models for cluster and trying to enhance the fit among the data and models is denoted as Gaussian mixture, and here is distribution as Gaussian and Poisson. Next, unsupervised nonlinear clustering algorithm. Here the MST based kernel k-means clustering and density based clustering algorithm is involved in this section. Kernel k-means clustering algorithm is like same as the k-means, but the major change is the calculation of distance, and it will also replace the Euclidean distance, and some of the advantages and disadvantages are shown here. On the right side, the basic algorithm will be shown. Density based clustering algorithm. Density based clustering algorithm is a crucial part in finding the non-linear shape structure based on the density. The density based spectral clustering algorithm with noise is the most commonly used algorithm. Let example the beginning with an arbitrary point and initialize the neighborhood point by using if sufficient point around the cluster, then marked as the label as noise. A new unmarked point is processed to lead further noise. The point leads until all marked as noise, and some advantages and disadvantages are shown here. Now I am going to show the MATLAB function which I used for this project. So this is the basic output for the fingerprint image segmentation. And this is the edge based technique. This is a hierarchical clustering output. It takes some time. Yeah, there you go. So this is the centroid clustering phone. Also this one, the center pixel has been marked as red color. The related works are Balin and Ayin chakra classification techniques. He put the feature based technique will extract the delta and coarse in fingerprint based on histogram. Also, Weeble classes such as whole and twin loops and Lozio loops such as arch, tended arch, right loop and left loop has been very clarified in this technique. Next, the Jain, Prabhakar and Hohn's multi-channel classification approach. This algorithm is for finger code based on two-stage classifier. The first classifier will use the k nearest neighbor classifier, and the second classifier will use a neural network in its second stage to categorize a feature vector into the one of the 5 fingerprint classes. So this is a summary and conclusion for this project. The experimental results of the segmentation algorithm will be discussed in the above section. I used FVC 2000 database for the fingerprint image. Additionally, there are a lot of softwares available in the research areas such as Asian Laboratory at Stanford University and MIT for geonomy research for the use of Geni cluster software. In addition, SPATI2 in Fortran 90 to analyze the data grouping in cluster and Veka software. So these are some disadvantages in this clustering models I have found during my research. So the future work will be the modifying the exist work algorithm for fingerprint segmentation such that linear and non-linear unsupervised clustering algorithm, and to partition given image into sector as per corresponding minutia points to achieve the high security. So these are some reference of my project. I would like to thank Dr. Dabang Oliver Wu for his wonderful class lecture and his guidelines for this project title in the pattern recognition course. Thank you for listening.